Hey everyone, so today I want to begin by going over lesson 4, and it's going to cover chapters 11 and 12. My name's Heather McPherson, and I really do hope that I can give you a little bit more insight into these chapters and how to figure out different ways of solving these problems. So, first we have Ephraim and Devont were asked to reflect the pattern block figure over the horizontal line through the center of the square. So here on the left, we're going to have the first figure that they were asked to reflect. You have two triangles, a square, and a trapezoid. Now, in order to reflect the block figure over the horizontal line through the center of the square, you're going to rotate it about 180 degrees. Once you rotate it 180 degrees, you'll see that the trapezoid will now be on the top of the figure. The square is going to stay the same place, and then you have your two triangles at the bottom. Again, this is just rotating it 180 degrees, so halfway around the whole center. So now we're going to look at a couple of different shapes, and we want to just pretty much determine if they're symmetrical, and if so, how are they symmetrical? So on this next slide, I've got a few of the shapes, and we're going to take a look at this one right here. Now, it can be symmetrical if you rotate it 90 degrees and then rotate it another 90 degrees, you get the same figure you had. Same as this one, you're going to rotate it 90 degrees and then another 90 degrees. So 180 degrees, you're going to get the same object you started with, which is rotational symmetry. Now next, on these objects here, I just went through and I put the lines through them. So these lines of symmetry, as long as the shape has at least one line of symmetry, like this triangle right here or this triangle down here, then it is symmetrical. Now, this one has two different lines because you can either fold it halfway from the middle like here, or you can fold it halfway in the middle here, and you're going to get the same shape. Now, there's more lines of symmetry. I just kind of went through and did some main ones. Like for this rectangle, you have, actually, I only put 4 lines of symmetry on the rectangle, but you get the gist of what it is. So as long as, again, there's one line of symmetry, then the shapes are symmetrical. Now, we want to know if the following figure forms a vertex figure. Here we have an octagon, a hexagon, and a polygon. Now, it does not form a vertex figure. Okay, so now that we know it doesn't, why does it not form a vertex figure, you ask? Well, first you're going to have to find the total surface area of each shape. And here we have the polygon is 108 degrees, the hexagon is 120 degrees, and the octagon is 135 degrees. So now what you'll do to get the total of the figure, you're going to add those up. Well, in order for it to be a vertex figure, it has to equal 360 degrees. So this does not equal 360 degrees. It actually equals 363 degrees. So that's what makes it not a vertex figure. So just remember, when you want to figure out if a figure forms a vertex figure, it has to be a total surface area of 360 degrees. Next, what are the relationships within this figure? So we're going to dig a little bit deeper into this figure, and I'm kind of going to break it up a little for you so that you're not looking at the whole figure. We're just going to be looking at parts and describing the relationships between them. So here we have, on the first part, we have the triangle PQT and the triangle PST. So, are the triangles QPT and SPT congruent? Well, yes, they are congruent. And the reason they're congruent is because line PT is congruent to itself, So it's based off of the side, side, side property. So each angle, each point, and each triangle is congruent to itself. Now, here we have the angles. Angle P, angle S, angle T, and angle Q. So, are the angles QPT and the angles SPT congruent? And the answer to that is yes. And the same way with the triangle QPT and triangle SPT are congruent, so are the angles. So the angle P is congruent to the other angle P. The angle S is congruent to the angle Q, and the angle T is congruent. All right, now that we looked at triangle QPT, now we're going to look at the triangles PVQ and PVS. So tell me if the triangle QPV and the triangle SPV are congruent. And the answer to that is also going to be yes. Let me move this for a second. If you can see right here where the angles are congruent just as the triangles are congruent. And they follow the side angle side property. So you have this side, so line PQ or QP, and then you have angles, and then you have the other sides. So they make it congruent because of the side angle side property. Move this back up here. So is angle QVP a right angle? Well, you can look at it and you can definitely tell that it is a right angle. And that's because it has this little box. It makes a pretty much a square if you draw it in. So yes, it is a right angle. And also because the angle V, this side has to be one angle, this side has to be. And they're congruent because they're supplementary angles. And for it to be a supplementary angle, we learned that a while back, it has to equal 180 degrees. So if you have two angles right here on this side, on the right side and the left side, and they have to equal 180 degrees, then it'd have to be 90 degrees to make it even. Now we're going to look at some other shapes and the relationships with angles of penta and PQR. Well, what's penta and PQR, you ask? So here we start out with a pentagram, polygon, and you have points P, E, N, T, and A. So here's penta. Well, on this shape, we also have a equilateral triangle, which means that all the sides are the same, and that those points are going to be P, Q, and R. And these two shapes are inscribed by this circle. So now what we want to do is we want to look at, there's one central point in all three of these shapes, and we're going to go ahead and make that O. And now we're going to go ahead and have a line QO and a line NO. And what we want to find out is the measure of that angle. So this triangle here, we want to know what this angle is. So your measurement is to find angle NOQ, and that is actually going to equal 24. How do you get that, you ask? Well, you've got to remember that the central angle of a pentagram is going to be 72 degrees, and the central of a equilateral triangle is 120 degrees. So you take 120 minus 72, you get 48, divide that by 2, and you're going to have 24 degrees. And, oh, sorry about that. I know I keep having to move that around. I didn't realize what I was getting at. So we're going to look at this picture right here. And you have a girl holding a ruler, and she's looking out at a cliff. Well, we want to figure out how high that cliff is. But how do we do that? So you're going to start off with a couple of equations. The first one is going to be the ruler, which we know is 2 feet from her eyes, divided by the distance between the ruler markings, which is 1.5 inches. That equation is going to equal the distance from the cliff, which is 1/4 mile, divided by the height of the cliff. And again, we don't know the height of the cliff yet. That's what we're trying to figure out. So now that we're going to transpose this equation in order to find the height of the cliff, and we want that to be on the left side. So we will have the height of the cliff over the distance from the cliff, which is 1/4 mile. 1/4 mile is going to be approximately 1,320 feet. That's going to equal 1.5 inches over 2 feet. So we can't have feet, feet, and inches. So we want to make everything into feet, right? So the new equation then is going to look like height of the cliff. Okay. Other than going into all feet, we also are going to multiply this 1,320 feet to both sides. That way we can get height of the cliff by itself. So it's going to be height of the cliff equals 0.125 feet, which is 1.5 inches made into feet, times 1,320 feet divided by 2 feet. So the height of the cliff is going to approximately be 83 feet. And again, we're given most of the information. All you have to remember is how to transpose the equations, and also to make all of your all of what you're using to multiply, subtract, divide. You want it to be all inches or all feet, or you don't want to mix match them. So in this case, we wanted to go in feet to find out how high the cliff was. So I really hope that I was able to, kind of give you a little bit more intel to solving problems like this, word problems, shapes, symmetricals. But anyways, I hope y'all have a good night. Thank you.